I'm CK. Today we've got a module from Ginkosynthese, their magma compressor. I've done one other module from Ginkosynthese. It was their seeds VCO, and I liked it quite a bit. So we'll see how their diode compressor goes together. Now, I'm not going to talk a lot about the theory of compression or all the nuances, which are very personal, on how you may want to apply it in your audio chain. There are many better resources both on YouTube and in text to do that. I don't want to interject that piecemeal in a build video. We're going to build it, see how easy it is to build, and then try it out in a very practical sense. And I hope you enjoy the video. Here's the bag, and as usual I got this from thonk.co.uk. It's got knurlies inside, even though I got plenty of knurlies, because I bought like 200 packs because knurlies are so handy. And it probably also has a panel nut wrench, which, since I've made so many Bufaco kits, I've got way too many of those. Oh, it looks like it doesn't actually. Huh. Let's see. The circuit board and front panel are in here. Here's the instruction sheet and bill of materials. Bunch of resistors, and it should be a bunch of diodes too, of course. And then R18 is 0. Use a clipped of wire, in other words, just put a jumper in there. And then, yeah, we've got 8, 41, 48. That's the kind of orange and black glass diodes. That's what will be doing the compression in this. And then 2 black diodes for power conditioning. But let's look at the front panel and circuit board first, because that's the fun part. How do I get the bag open? The bag is too smart for me. Fortunately, I have tools. Okay, I'm a little confused about this. So we've got this piece of aluminum. We've got this piece of aluminum. This looks like obviously a front panel the way one would typically expect it. In envelope, control voltage for something or other, I don't know what, attenuation maybe, and out. Gain, envelope, attack or attenuation. It's got 2 T's, so I'm not sure. These are probably LEDs to let you know what's going on. Recovery, then a something or other goes in there. And if you look here, it goes all the way through the circuit board. Release, which is a pot, and then compress, fast or slow attack, and comp in. Is that compression in? I don't really know. So release is here. And I'm kind of trying to lay this out because the switch is there, and this comp in is, looks like it's a switch and an LED. Okay. And where is the ladder of diodes? There's 4 of them. Again, we're looking for 8 of them. Here's the power connector, and that's where these two conditioning diodes, or voltage protection, current protection diodes, I'm sorry, use the right word, polarity protection diodes go. And then, it didn't say 4 of those, did it?
No, just two. Huh. And then a IC here, which is the TL072 op amp, I believe. Let me double check that on the list. No, that goes in IC1. Okay, what goes in IC2? IC2 is, IC 2 and 3 are TL074s, more op amps, just more internal stages. So that's that. Again, I don't really know what this is. There's a build guide, of course, so I'll bring that up in a little bit. And we'll look at the board again some more. Some capacitors. This is version 1.1, March of 2022. Ginkosynthese Magma. So I guess Bufaco puts this together for Ginkosynth. Okay. It definitely is not your typical Bufaco board because many of the traces are almost straight. Only a couple of them are wandery, like Bufaco likes to do. Look, it looks like we've got two capacitors on the back of the board too. So if you're looking for a capacitor and don't know where to put it, three of them actually, don't know where to put it, it'll go on the back. And a red to let you know that that's the side where the red stripe on the power cable goes. Got other things in here. We'll put that aside for a second. Oh, I see. I see. Now I know what that is. Here. We've got an opalescent marble that looks like it kind of gets captured there. I don't know if it does anything. I don't know if moving it does anything or not. I don't think so. It might. No, I don't think it does. But I could be wrong again. We'll take a look at it later. But that's kind of neat. That's fun. We'll look at the rest of the stuff in the mechanical bag since I opened it up. Big knob, no set screw, no serrations on the inside, so it's a pretty cheapy knob, but it's not bad. Same with this one. And we've got some 10K, both B taper, and another 10K B taper, and then some of these tall guys. These are 10K also. That's 1 0, that's a 10 with a 3, and that's 3 zeros after it, so that's 10K. 10K, little momentary, no, it's a locking switch. And there are the knurlies to mount it. One switch. So it should be, oh, I get it. This switch is the, I guess this will go here. That's compression in or out. And excuse me, there might have been a camera jump there because I just sneezed and I don't need to sneeze on camera. So that's the mechanical stuff. And here we've got the electronic bits. Oh, and another power connector, of course. A bunch of resistors. Those are 1/4 watt. These all look like 1/4 watt resistors in this kit. So that's all the resistors. I'll put them there because they're going to go on first anyway. Then some NPN transistors, 3904s. Here's our op amps, the 4-stage one and the 2-stage one. Here's our diodes, which are going to be doing the compression. And then we've got some electrolytics. What size are these? These are 100 microfarad, 25 volt. Just perfect for eurorack. And a couple of film caps. And some 104, 100 nanofarad decoupling caps. And I think that's it. And again, more LEDs. So it's a pretty straightforward kit, except for, again, I'm not sure what the heck this is. Unless we want to put it... Oh, we do put it on the back here, because it's got... That's interesting. I wonder why they've got a backplane for it. But you can see it's got cutouts for the capacitors that are going to go on the back, and hole for stud mounting, and for putting the power cable in. I wonder why they went to the extra expense to make a back panel for it. Don't know. Maybe something will tell me, even though, again, I believe when I follow the QR code, it'll probably be fine. I'm trying to see what they say about the ball at all. And they don't say anything about the ball. But that's the parts that came in the kit, and I'm going to turn the soldering iron on, get that heated up, and I'm also going to go try and see if they do have a build guide just to give me at least some information on what that is for, if it's for anything other than just attractiveness, and why they put a backplane on it. So back in a little bit. I went to Bafaco's site, and then I went to Ginkosynthese site, and I am none the wiser. Ginkosynthese has their build manual, and the build manual is just a PDF of this sheet of paper. So, I don't know. We'll figure it out, or we won't. So let's, we typically do the resistors first, but I may do the diodes first. I think I'm going to do the diodes first, because they're the star of this show anyway. Yeah, if you want to learn about how diode compression works, it takes advantage of characteristics of these Zener diodes, and there are good references online that you can read up on the characteristics and why diode compression is interesting. I'm not going to go into it in this video because I wouldn't do it justice. And hopefully, if I remember, I will put a link to one of the resources I've found about diode compression. The guys who do the EduSynth series have a real good PDF of diode compression that I can highly recommend. But first, I'm going to go ahead and put diode 1 through 8 on. And here's 1, 2, 3, 4. Where's 5, 6, 7, 8? There it is, 7. 1, 2. There's 7 and 8. Where's 5 and 6? Always. There they are. 5 and 6 are there. Interesting. So I'm going to put 1 on, and we'll solder it in place just to get a feel for how the board is taking solder, even though it's a Bufaco board and I have a huge amount of confidence in the quality of their boards. The other thing you'll notice is you don't want to bend the diode leads right up against the body because the holes are kind of spaced far apart. They're spaced apart for the polarity protection diodes, not for the 4148s. The other thing is the solder holes are really big for these diodes, so we get real good flow through to the other side. So that's one diode. I will go ahead and again, there's a little white, a heavy white line to show you where the black cathode side of the diode should go. So I'll go ahead and put the rest of these on in and speed the playback up with no commentary. And that's the diodes all in place. Nothing particularly interesting about that. So now, see, it's a little bit unfortunate. He does the resistors in order instead of by value, so I'm probably not going to go in order like this because I'm jumping around between resistor packs. I will probably just do the 100Ks, then do the 10Ks. Let me see what's the most. Hundreds, tens, and 1Ks. So I'll be skipping around. And when I do that, I do indeed mark them off as I solder them on so I don't confuse myself, because that can happen very easily. So we're going to start with the 10Ks, and there are 2, 4, 6, 8, 10 of them. And again, not much to say about them. So I will turn the playback into rapid speed, probably cut some of it. I mean, I know I'll cut some of it. And take out the commentary because there's not much to say about the resistors. And while I'm putting these on, I will be listening to WQXR FM out of New York City on their iPad app because I'm in California. Best classical music station in the world. And I'll be starting with Giselle's Suite by Adolphe Adam by the Vienna Philharmonic Orchestra, Von Karajan conducting. So, enjoy resistor time. And resistor time is over for another kit. You can see them all there. Some blue, some green. Don't fret about that. They're all, again, they're all quarter watt. Pretty small. And as I was putting these on, I saw the way this works on the back here. Besides the 3 capacitors, you'll notice right here there's one LED and then another LED. I believe they're red and yellow. So what will happen is the red and yellow LEDs are going to shine against this ball and do the whole, that's part of the magma conceit in the name and the thing. I do think the build instruction should mention that you have to capture the ball in there, and they don't anywhere. To the best of my ability, I'm just double checking. Yeah, they don't. And they should. I can see some beginning or intermediate builders who might not know what's going on there. But the next thing we're going to do is put the sockets on the board. Oh, and I guess that's why you got build videos like mine, to tell you these things that are not explained in the build guide. So the notch in the socket goes to the notch in the printing on the circuit board, and I forgot to cut another piece of solder after doing all those resistors, so I'll just use this last little bit on this one to tack this one leg in. Double check it, and as you can see there, I hope, yep, it's cockeyed, cattywampus, so I just heat that solder up again and press on it, and it flattens out. Now I could do the rest of the legs, but I'm going to put the other two sockets on the board before I do, and get another piece of solder. I go through a lot of solder, as you can imagine. And that's the sockets. Now we're going to put the capacitors, C1 through C6 are the 100 nanofarads. Mine direction, I mean, I'm not sure. Oh, that's C9. So let's get the 600 nano, 104 cap decoupling caps. These will typically go very close to the integrated circuits. They, for lack of a better, to not go into a great deal of depth, they condition the power for the chips so the chips do well and don't suffer from undue power flux or capacitance, or inductance or whatever. These caps, oh, that's one thing I did want to point out. Some of the printing on the board for the resistors and the caps is a little bit hard to see, and you need to look closely at it. And by the way, there's 18, there's the jumper I put in. And some of the resistor values are above, and some of the resistor values are below. So just be patient with yourself and look for everything. So now we'll put these caps on as I can find them. Now all the capacitors are done. Now we will do all three transistors. And as typical with components on tape strips, I just cut them off. I don't try and manipulate them out of the tape strip. I don't try and pull and grab and whatever, because you bend the legs, you can potentially damage the component, so I don't do that. Now the markings on the board show very clearly where the flat side of the transistor goes, which is always helpful. I'm not going to solder them right this second. I think we'll do the LEDs. Oh, that's the one on the back. I guess we can do the LEDs on the back. We're going to put the red LED on the bottom side of the hole, yellow LED on the top, and I'm going to assume this is the yellow LED, but I can check that now if I can find the dang thing. Because a little while ago I made this, which is from Velleman. It's the LED Buddy, and I can put the LED on these two pads, and yes, it is a yellow LED. You can see the yellow, and we can also read it's got a forward voltage of 1.9 volts, 6 milliamps. This is running 5 volts through it, and if you were going to put current limiting resistor, you'd use a 470 ohm one. This is a very handy little device. I like it quite a bit. And again, I'll try and link the video in the description below, but if I forget, then just think, look up LED Buddy on my channel, and you'll be able to find it. Now I want to make sure I get this right. Not that I really need it to be perfect, but I mean, if red's on the top and yellow's on the bottom, that would not be the end of the world, but I'm going to do it the way the designer of the kit wants to get the effect he wants. And while we're here, and he does mention it, I'll go ahead and put the power header on, and as you can see, it's a keyed power header, and there's a mark on the circuit board to show you where the key side goes, but because we are paranoid, I'm going to take power cable and match the notch to the connector, and that does put the red stripe in line with the word red on the back, on the printed on the board, which is the negative 12 volt rail in. So just like the sockets, I'm going to do one pin. I'm going to try and do one pin. I'm not getting my spacing right. Do one pin, take a look, and I know I moved it when I was doing that, so I'll just heat it up. Now you may be able to hear it. Nope, it didn't click, but I pushed it down flat. So we'll do all the stuff on this side of the board. Now we'll go back on the back and solder those transistors in. Now that is all the electronic components except for these LEDs, and we're not going to do those until we are putting the front panel on. So we will take our pots and set them on first. And in the instructions he calls these green. They're not obviously green, but they typically there's one manufacturer who makes these style metal shaft pots in green, and again these are all 10K, so they're all the same, and he lists them as green, 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 and then the blue talls, but ignore the green and just say the shorter ones with the metal shaft are what's green, according to the notation in the build guide and the recovery. Now he says to put the jacks in now. I'm going to drop the LEDs. They go here. I'm going to drop the LEDs in now just because I have a little more room. Again, I'm not even thinking about soldering these for right this second, because they're going to want to poke through the front. And there's one LED down here. Now I'll set the jacks in place. Now I'll put the switches in. This one goes here, and this push button goes here. Now we're going to put the front panel on, and I'm going to put that there just to make sure our spacing comes out correctly. I haven't soldered any of these controls yet, as you saw, because it's not time yet. Now we've got them all in there, and I'll get my little clamp and clamp the two boards together like so. And the next thing I'm going to do, and you can do this whether you have a clamp or not, this is what I do sometimes. I'm just going to solder one
of the jacks here, and then I'm going to solder one of the support legs of this potentiometer here. And then I'm going to pick it back up, and I'm going to put one fancy Bafaco panel nut on the one I soldered. Bring it on down, finger tight. And then take the one I soldered the leg on, which is the release, which is absolutely the wrong thing, because that one's not, doesn't have a threaded top, so I'll do this one too. My camera's timed out, so I missed a couple of seconds at last. So we've put a panel nut here and a panel nut here, and used my little Bafaco tool to tighten them down. Now everything is fine, and we can do the rest of the leads, but we're also going to take all the LEDs and poke them through the front of the panel. Now we can solder everything, and I am going to do the LEDs first simply because they have the highest potential of actually moving, and I don't want to do that. So fast motion to solder all these connections, and I gotta unlock my iPad, and we'll be listening to Symphony Number 4 in C major by Andreas Romberg, with the Musicum Basel Orchestra, Kevin Griffiths conducting. And now that we've got all the stuff soldered on the board, I took the panel back off as my water heater was going on. And I like to, even though the pots are a little bit in the way when I do this, I just like to wait until the absolute last second to put the chips in, just to protect from any potential last minute extraneous charge or static electricity. Even though chips are pretty, they're not as delicate as they're all made out to be, but you do want to be careful with them. And again, just remember on this one, it's a dot, not a notch. And it'll go, you can see the dot a little bit underneath the chip, underneath the socket. This is the only one that's at all challenging to put in because of the pot. But there it goes, and now I can put all the front panel components back on again. The front panel itself on again. And the little ball is going to jump out. And we'll put the knobs on, make sure everything's counterclockwise. Aim the dot at the C for no other reason than I feel like it. Yeah. Again, not great knobs, but they're okay. And there we go. Now we'll go ahead and put it in the rack and see how it sounds. I'm going to start with a frequency central drum. Now you can see, let me bring the scope in. You can see on the scope, the top line, the yellow line, is the unmodified signal. The bottom line is the output signal coming out of the compressor. So I've got things kind of halfway up, except for gain all the way up. Let me turn the compressor on. You can hear a little bit of sharpness there. If you look at the scope, you can see right after the peak there's a rapid fall off, more rapid than without it. Let me change the attack to slow. Now you can see, you saw that move, I hope. You can see that slope getting longer on the magenta line from the peak down. Let me turn it to fast attack again. You'll see it's much more abrupt. I'm going to leave it there for a second, and I'm going to turn the compressor all the way up. Look how it takes that, look how it thins that out. It's all compressed down. I'm going to take it back, way back, and then you can see it's starting to grunge up at the top, and I'm going to turn recovery up. That sounds pretty neat. Let's put some compression in on top of that. Now it's got a slope on the outro. I'm going to turn it to slow again. Turn the recovery down a little bit. Turn the compressor down a little bit. That's certainly useful. I'm going to change drum sounds. Ooh, look at that. I'm going to take the compressor out for a second so you can hear what that sounds like. Change to another drum sound. Take the gain out a little bit. And again, we can flatten it out. Let me turn that up. We can flatten it out to be very, very low, and then take the compression back out. Oh, that feels good, doesn't it? Turn that up a little bit, speed it up. I'm going to slow this down a little bit again because I want to add the LFO into envelope just to see if that does anything. I don't know if it's gonna. Oh yeah, listen to that. I'll turn the LFO speed up. Okay, at that speed it doesn't much matter, but take it back down again. And this is just a trigger, it's not a slope. I'll change it to a triangle wave. And turn the see how it falls off? Beat, beat, to say beat, beat, envelope off. Beat, beat, different envelope. Beat, beat, different envelope. That's kind of neat. I'm going to do this into, I'm going to put the LFO into CV right now. I don't know what the heck that's going to do. I actually don't know what that does, so. I'm going to take the release out. So I'm not getting anything out of CV, but that's not the unit's fault. That's my fault. I don't know what it's supposed to be doing. Now I'm going to do one more thing here. I'm going to take, if I can, yeah. I'm going to take the output from my, what the heck am I doing? I'm going to take the output from my even VCO. Oops, I'm sorry, I'm going to be triggering the even VCO from my whatever. Now I want to do, I'm sorry, I'm confusing myself. Now I want to go into the mixer and take the sound out from both the drum module and the even VCO. Let me turn this on, make sure I got it at least halfway right. I do, but I don't have the drum coming in. What did I do? I forgot. I did something. Oh, I'm coming out of the mix into there. Oh, I can't. Is the drum coming into there? Oops. We just had a little reset, which is always fun. I'm going to pause the cameras just for a minute, or I'm not going to pause the cameras, but I'm going to speed it up while I rearrange cables because I'm a little confused as to where I am, which is not unusual. So we've got the drum. Drum is going to there, and then to there. Oh. And the gate on the drum. Oh, okay. Okay, so I've got the compressor out again, and I've got the even VCO and the drum going. Now I'm going to take the compressor back in. And you can hear right now that the VCO is overpowering the drum beat, but when I kick the compressor in, it makes it stand out some more, which is ultimately one of the main uses of compressors, is to even out a mixed track. Now I'm actually going to take the drum completely out and hear what this sounds like simply with Oh, I'm sorry, I'm not going back into the VCA. Let me find another. I've got too many cables right now. I know it's a hard thing to say, isn't it? I'm going to take it out of here and put it into here. See the way it's compressing that down? See there, it's making it a little crunchy. It's got a peak and then it falls off. Now I'll bring the drum kit back in, even though I don't know where I'm supposed to be here. Oh, I can use this. That's why it fell into the rest of the crap. There, that's almost balanced. So that's what we got. It's a pretty good unit. As you saw, it's pretty straightforward to put together. I do think that they should at least make a note in the build guide, capture the ball between the two, between the circuit board and the front panel, because I think some beginner or intermediate builders would be confused by that. But it does what a compressor is supposed to do and adds some. You heard how it can really make those drums very crunchy. It's nice. And it's a good unit overall, and I think you could find a place for it in your rack. And I hope you enjoyed the video.